Hello everyone and welcome back. This is the preview of the Smoke Sim and I think it's working quite well the way I expected it to work. And the main thing for me is when the smoke is being emitted, it's colliding with the remaining of the geometry or whatever is left of it at that moment. So let's see how we can use. So this by itself is a great effect. Like we can use this to and render that and just increase the resolution of the sim. But we'll dive more into smoke and at a later chapter. Right now, I just want to create basic smoke sims and use them to drive the particles. So we have our particles, and one of the areas is what we're interested in, which is this one. And I'd like to cache it to make things faster. And I've done this already. I've cached the source for the smoke here, and the collision as well. So it's faster to just to read from disk. All right, let me copy this, plug it here, and call this source PTS dynamic for points, and it's dynamically changing. Dynamic and V1 control middle click here, so it restores that the expression, and now it's going to cache. So the source is then caching, and this is the particles that we have. It's a bit slow towards the end, and we still have one thing that we need to fix, because if we start emitting from this, it's going to continuously emit, obviously, as we go here. So we need to do that same trick that we did before, and I've already made an ID attribute in when we sourced this from the same setup before. So I'm going to use a time shift, and for this maybe let's go negative -5, so we get like a big gap, and we're going to create the same trick. So here I'm going to say at scene is equal 0, and then name it here at 1, and then copy attribute copy from this to this, match by ID, and the attribute is scene. Let's check this and look at the scene attribute. So it's there, and blast. We could do the same thing for the points, for the smoke as well. If we want to only emit instantaneously, that's fine. But in my case, I want that source to be always coming in, so I kept it this way. But for the points, maybe we make, no, I think this is gonna be fine. We'll emit a big chunk off of this. Let's see how many points we have. It's a bit high, so I'll reduce it as a post process, but I'm gonna save this to disk and override the previous one, because I don't need the previous frame to be available. Sorry, I don't need the full data to be available every frame. Okay, so this is how the source looks like for our particles, and let's plug it into this one. So let's replace this one, and let me move this part here down, and I'm gonna version up, and let's go inside. So we have this the source for the smoke with velocity and all of that, and then we have the particles, and let's go inside. Pretty much the same everything. We don't need to change anything except that the particles are too much now, so I need to lower this count so it's faster for us to work with. Yeah, 5.4 in just 2 frames, or half of the frames. It's too much, so I'm gonna delete and keep 10%. I'm gonna do this using a wrangle node. I'm gonna say random at ptnum. So I'm gonna use this expression rand and ptnum to generate a random number per point. So it's gonna give us a value that goes between 0 and 1 all the time. And we are certain that each point is gonna have a value between 0 and 1. And each point has a unique value. It's not gonna get, there's no point that's gonna get the same value. So we can say if this random result, if this rand result is less than 0.1, I want to delete the points, which means that we're going to delete 90% of the points. We're going to keep only 10%, because this is what the random number will be for 10% of those points. So let's write this. I'm going to say if, open parentheses, and execute the function that we want, which is random pt number. If this result is less than 0.1, I'm going to open and close the brackets. And here we're going to put what we want to execute under this if statement. And we're going to say I want to remove point. And this is a function in Houdini. And you can see it's blue. And it basically expects where the data, where is the handle for the data that you want to remove. And what is the point number. And the point number is at ptnum. So this will get executed every time this condition is correct. And let's see. So it only deleted 10% of the points, not 90%. I'm going to increase this to 9. And now we are left with 10%. See, 3970, and here it's 3960. It's basically 10%. So let's increase it a bit more to 7. We keep 30% of the points. And let's go back. And let's hit play. And now we're emitting. It's being affected by the force, by the smoke, and everything is moving as expected. Let's take a look at it here. Let me hide this, disable that node, and now we have this. All right, let me lower the points one more time because I do think it's a lot. And I'm going to increase the force advection here, maybe 1.2, just make it a bit stronger, and also the source of the velocity coming in from the points. Let me make sure we still have that attribute. Still have a v attribute. Let me check. Yeah, I want the points to have a stronger velocity. And I'm gonna push the points being emitted back a bit, because if we just leave it as it is, it's just gonna go too fast in this way. So I'm gonna push it backwards a bit, and let's hit play. Yeah, it's working. So let's take a look at the points here, and with a black background. And you can see we are dissolving the geometry. Where is the remaining of that? So we are dissolving the geometry, and let me use a VDB convert so we can see this better. I'm going to convert this live into a polygon mesh. Disable this, and this is what we have remaining. And let's visualize the points here. And now if I hit play, or just scrub through the timeline, you will see the dissolving is happening, and it's being converted into a volume right away. And it's eating away the geometry, and all of it is interacting together. But if we notice, if we look closer, we see that the points are moving inside the volume, inside our mesh here. At some point, it's just started going through that. And I don't like this. I want to fix it. So we also need to collide the particles with our geometry. And because this is an SDF, an SDF, this SDF has information that are unique. So if we convert it into an SDF, the data inside has some useful information. And what it has, basically, it has something called gradient. And what gradient is, it's the vector or the force or the distance needed to move this point from here to the closest shell. And if we dive inside, this force is going to be stronger, deeper. Okay, at the edge, at the top, it's going to be too shallow, so the velocity or this gradient vector is going to be too short. As we get deeper, we can tell how far we are from the surface, and it's going to be a vector that basically pushes the point from this all the way to the shell of the surface, and which is the isosurface. So if we look at this, for example, these points have a lower density than the points inside. And the density where it's the least strong, has the least amount of density, that's the isosurface. And so if I scatter points on this geometry here, and then use a a point VOP, and connect this data, which is actually, let's connect, where is it? Let's make an SDF of the entire geometry. So this one, we'll make a, oh, not from this one, sorry. We'll make an SDF from this, VDB from polygon of this geometry. So I have an SDF here, and let me move it all the way here. And let's say we have points, and I'm going to connect this second input and tick on fill interior. And if I dive inside, we can query data from that SDF. So I'm going to use a node called volume gradient, and I'm going to connect the second input or select it here, and then the sample position is here. And if I connect this to the normal and display it, you will see that we should have primitive number. Let's see, surface. Yeah, let's try to, I think I changed the viewport to reduce the length of the normal. Yep, so if I look at this normal, you will see that it's a vector. It goes from inside all the way to outside. And so we're taking these points and using them to query data from here. And this is just a surface. So we're querying the gradient of this data. We can also use a VDB analysis node. And if we have a density field, for example, like this one, if we are working with a volume and we don't have an SDF, we can use this VDB analysis node and say, I want you to take the density field, compute the operation. I want you to compute the gradient and give me a field called gradient. And I can also, I'm going to copy this. I can also run the same operation here, but we cannot use this because this node gradient works on an SDF. So I need to use a volume sample vector. So this node allows us to look up vector data or vector field from an input. So second input, yeah, it's working there. It's different, obviously, because we went through a different process, but overall it's pretty much the same. So what can we do with this then? Well, if we go back here, and this is our out collision, I'm gonna move it, and we're gonna do the same thing. So I wanna say if my data, if these points are inside this, I just wanna move them outside. Okay, if they're inside this volume, I wanna move them outside. And I'm gonna use a point VOP here and here. I'm gonna use a volume gradient and second input. Actually, I don't need this, just second input. And then the name, I want to specify it, make sure that is correct, called collision. In this case, the SDF is called collision. You can use a primitive number, or can use a number here, and that would be the order at which these channels are placed at. So this number 0, primitive number 0. And now let's take a look at this gradient. And you can see the points that are inside, they have a gradient information. So all I'm going to do is I'm going to take P and add this vector to it, and then move it. And let me change the background to light, and let's remove this alpha thing. And I'm going to use a VDB convert so we can display it and we look at it easier. This is the points. It's going to be tricky to see, but if I go inside here, I don't have any points. And then if we go to the previous frame and display this, we will see that we have points inside, but now we moved them out with this process. And if I play through, you will see that the points are jumpy now, but they are not colliding anymore. So we can do a quick, simple thing. If we don't want to overcomplicate this process, we can take this collision geometry, and I will do this now, and I'm going to call it out geotemp. So I'm simply converting this into a geometry. I'm going to copy this and go inside the DOP network, create a static object, and set the path. We have to tick on use deforming geometry because the geometry is changing every frame. And I'm going to copy the collision and say this is my SDF and use this as the volume sample data. And I'm going to merge this. This is very important how you connect them. So always connect all your collision together and then plug that into the merge. And now if we hit play, we should see the particles collide with the geometry nicely, and it's being updated every frame. they're bouncing at the moment, but they are also colliding as we would expect them. So let's change the settings of the collision here. I'm going to lower the bounce. I'm going to lower the friction, and here as well. And I'm going to change the collision behavior to slide. So if it collides with the geometry, I want the points to slide along the geometry rather than bounce. And this is going to make them wrap around the geometry, and see they're not bouncing as much as before now. All right, let's cache this pop effect by new smoke. Control click this. I want to cache this result to disk. We can take a look at it in the next video. Thank you for watching, and see you in a bit.